Alright, topic 14 is on volume, and here are the formulas that you're given on the exam for volume, cylinders, which are cans, pyramids, like in Egypt, right circular cones, which are like sugar cones, and the spheres are balls. You also have to know, or should know, a very early formula in your career as a math student. Volume equals length times width times height for a box. Here's some questions that are on the exam about volume. Here's one off a previous exam asking you to find the volume of the pyramid. So keep in mind that the formulas are on your exam, on the back of your exam. The formula for the volume of a pyramid is 1/3 the area of the base times the height. It says right in black and white here that capital B is the area of the base. In this particular picture, it says that one side of the base of this square pyramid is 12. Well, that would mean that the other dimension is 12 as well, and 12 times 12 is 144 for capital B. All that's remaining is to multiply by 42, and you got yourself your volume. So 1/3 of, well, maybe a calculator might be a good idea at this point in time. So I reached for my calculator and typed in just what I saw. Typing it into the calculator, it's important to make sure you do it the right way, and you don't want to make a mistake at the very end. So to type it in, you would type in 1 divided by 3 in parentheses times 144 times 42, and the answer is 2016 cubic meters. The number is the most important thing, but the unit of measure should be written on the side next to it as well. Alright, moving on to the next question with Tim. Timmy has a rectangular prism, which I just mentioned a minute ago is a fancy word for a box. And the box has a length of 10, a width of 2, and a height that's unknown. So, length of 10, width of 2, and a height that we don't know. He has another box that has a length of 5 and the same height as the original prism. We don't know what it is, but we do know that it's identical to the height of the first box. So we might as well call it X, something that we don't know. And we know that, but what we do know is that they are the same height in both boxes. What we don't know is one other thing, the width of the second box, which we can just call W for now. It says that the volumes have to be the same. Volume is length times width times height. So the volume of this box is length times width times height, which is 20x. The volume of the second box is length times width times height, which is 5 times W times x. They're telling us that these two volumes are the same. So if you're planning this out, you would write 2x or 20x equals 5 times W times x. And you want to find the volume. You want to find the width. So you divide both sides by x. And that actually eliminates the x from both sides of the equation, which is a nice thing. Dividing by 5 leads me to believe that the width has to be 4. Now that's a complicated question. there's a few other ways to work the question out. You could draw a picture. One thing you could do, which actually makes the question pretty simple, is they tell us that the height has to be the same for both boxes. So what you could do is you could just make up the number, let's say 6 for the height for both boxes. If you do that, the first box, box number 1, will have a volume of 10 times 2 times 6, or 120. For box number 2, if you used 6 for the height, you would get 5 times W times 6, or 30 W. They're telling us that the volume of the boxes are exactly the same, so you could divide by 30 to get the answer of 4 for the width. So it's a clever way to work the question out, which actually makes the question a lot less complicated. Alright, moving on to cans. The right circular cylinder is a can, and they're telling us the volume, and they're telling us the height, but what they're not telling us is the radius. They're asking us to round. There's a lot of information right off the bat. One thing we can lean on, though, is our formula for the volume of a cylinder. The volume is the area of the base times the height. In a cylinder is a can, and a can has a base that is a circle. It looks like an oval when I draw it in 3 dimensions, but that's just to make it look like it is a 3D picture. And you don't have 3D glasses, so it's the next best thing, I guess. So the volume's 1,000. They're telling us that. The radius is unknown. The height is 8. We have to put that all together into our formula to figure out what the radius is going to be. They're telling us the volume's 1,000. Since the area of the base is a circle, we're going to use pi r squared for capital B, the area of the base, and the height is 8. From here I would just get r by itself by first dividing by 8 on both sides. So 125 is pi r squared. I want to find out what r is. From here I could continue by dividing by pi. That's one route to get the answer. So you divide by pi, use the pi button on your calculator, and it gets you to the point where it says 39.7887 is equal to r squared. And remember to square root at the end to figure out what the radius has to be. About 6.3. Alright, sometimes it's good to think about other ways to work the question out too. And here's a suggestion on another way to work the question out. You'd still need to use the formula volume equals big B times H, which is pi r squared times H. And you know the volume's 1,000. You know the height is 8, but you don't know the radius. But you do have multiple choice possibilities to insert for r. This way you don't even have to solve the equation, you just have to try out the different numbers and evaluate the expression. If you type in to the calculator pi times 6.3 squared, multiply it by 8, you end up getting 997.5 approximately. Now that's not the same as 1,000, but of the choices it's the one that comes out to be closest to being 1,000. And the reason why it's not a perfect match, maybe you know, is because these answers are rounded, and because they're rounding the answer, it loses some of the accuracy. Alright, another example of a can. This is one that's more straightforward, where they give us everything we want, and they're just asking us to find the volume. So this is much easier than the first can that we did. They even give us a picture of it. The only small danger here is to remember that in this picture they're giving us the diameter is 12 centimeters, and we don't use the diameter when we calculate the volume. We need the radius, so the radius would be 6 centimeters. So we take that information and use the formula for the volume of a cylinder, and the volume is big B times H, which would be pi r squared times H. This time we're looking for the volume. The volume is pi times 6 squared times the height, which is 27. All the answers have pi in them, so we're not going to use the pi button on the calculator. Instead, we're just going to leave the pi in the answer. So all it's left to do is multiply 6 squared times 27, or 36 times 27. You get 972 times pi. I got pi times 972. That is exactly the same as 972 times pi. Alright, I left space here for one more question. I didn't dig too hard on the exam, but I know that another possible question they could ask you to do is find the volume of a sphere. Well, a sphere is a balloon or a ball. If they're drawn on the exam, sometimes they're drawn like that to make them look like they're in 3 dimensions. And let's just do a straight up question. Well, how about we make it a little bit more of a challenge? How about in this question, if I told you the volume was supposed to be 1,000 square or cubic centimeters, and I want to know what the radius was equal to, could you do it? Well, let's follow the formula and see if you can. The volume is 4/3 pi r cubed. I know the volume's 1,000. And that's all I know. I'm looking for the radius. So I have to find a way to get the radius by itself. One way to do that is to divide both sides by 4/3. So 1,000 divided by 4/3 is 750. So 750 is pi r cubed. When you divide by 4/3, be sure to put that in parentheses, or you will not get the right answer. You will not get 750. So that's how that begins. And I want r to be by itself, so I'm going to have to divide by pi to try to get r alone. So 750 divided by pi comes out to be approximately 238.732. And there's more on the calculator, more decimal accuracy on the calculator, but I'm just going to leave it as that for now on my paper. And I need to find a way to figure out what r is worth. To figure that out, I'm going to have to cube root both sides of this equation. On the Texas Instruments calculator, the cube root is found by pressing the math button, and it's the 4th choice down. So to get rid of cubing something, to get rid of something to the 3rd power, we cube root, just like getting rid of a square is by square rooting. So I would just type in to the calculator the cube root of 238.732, and it's telling me that my radius is approximately worth 6.2. You don't have to leave it as a mystery of whether or not you got the question right or wrong. If you wanted to take that r and pop it back into the equation, you would see that you get pretty close to 1,000 when you plug in 6.2. The only reason why it would not be exactly the same is because of the rounding. But if you typed in 4/3 in parentheses times pi, use the pi button on the calculator, times 6.2 to the third, you end up getting 998 approximately, which is not equal to 1,000. And remember, the reason why it's not a complete match is because of the rounding. So this is a good answer of 6.2. All right, that's a pretty good walkthrough of all the types of things it can ask you to do with volume, and it's a good bet that's going to be on the exam, because why else would they give you the formulas if it wasn't going to be on the exam? So be ready to answer probably one or maybe two questions on volume, and use the formulas to guide you along the way. This was a good video to see all the different possibilities of what could be on the exam.